In our previous lesson, we have learned how to convert a number in any base to base 10. In today's lesson, we will do the opposite, that is conversion from base 10 to any required base, and we will do that for all numbers. The process involved in converting a number in base 10 to any base is what I like to refer to as the long division repeated method. In this method, the base required to be converted into is used to divide the number, and the final remainder is recorded in each case. Let's illustrate this with the following examples. Change the following as indicated. Number 1. 1267 base 10 convert to base 8. Here, the 8 will be used to divide 1267 base 10. The first thing to do here is to set up your table as shown. The 8 will be written on the left hand side of the table, while the 1267 will be written on the right hand side of the table. The next step will be to use 8 to divide 1267, but we'll take the division gradually. 8 in 1 is impossible, so we combine 1 and 2 to make 12. 8 in 12 is 1. 8 times 1 is 8. 12 minus 8 will give us a remainder of 4. This remainder of 4 is not our final remainder because there's still a digit after 12. We place the 4 in front of the 6, making 46. 8 in 46 will give us 5. 8 times 5 is 40. 46 again minus 40 will leave us with a remainder of 6. This remainder of 6 again is not our final remainder because there's still a digit after 6. We place this remainder of 6 in front of 7, making the 7 67. 8 in 67 will give us 8. 8 times 8 is 64. 67 again minus 64 will leave us with a final remainder of 3. We repeat the process again by using 8 to divide 158. 8 in 1 is impossible. We again combine 1 and 5 to make 15. 8 in 15 is 1. 8 times 1 is 8. 15 minus 8 will leave us with a remainder of 7. The 7 again will be placed in front of 8, making that 78. 8 in 78 will give us 9. 8 times 9 is 72. 78 minus 72 will leave us with a remainder of 6. This remainder of 6 again is our final remainder. We repeat the process again by using 8 to divide 19. 8 in 19, that will go 2 times. 8 times 2 is 16. 19 minus 16 will leave us with a remainder of 3. This again will be our final remainder for this line of division. We repeat the process again by using 8 to divide 2. 8 in 2, that's 0. Since this 2 was not divided because 8 could not go in 2, we move the 2 over to the right as our final remainder. The whole process of division stops the moment I get to 0. Now to write my answer will be written using the remainders but starting from the bottom to the top. Therefore, 1267 base 10 is equal to 2363 base 8. Example 2. We again set up our table as shown below, and the digit 7 is used to divide the base and the remainder is recorded in each case. 7 in 2 is impossible. We combine 2 and 3 to form 23. 7 in 23 will give us 3. 7 times 3 is 21. 23 minus 21 will leave us with a remainder of 2. This 2 is not our final remainder. We place the 2 here in front of the next digit, making this 1 21. 7 in 21 will give us 3. 7 times 3 is 21. 21 minus 21 will give us a remainder of 0. 21 minus 21 is 0. Now 7 in the last digit, which is 3. 7 in 3 is impossible, so we put 0 and move the 3 over to the right as our final remainder. Since the 3 was not divided, it will be our final remainder. We repeat the process again. 7 in 33, that is 4. 7 times 4 is 28. 33 minus 28, that will give us a remainder of 5. We place the 5 in front of the next digit. 7 in 50, that will give us 7. 7 times 7 is 49. 50 minus 49 will give us a remainder of 1, and that will be our final remainder for this line of division. We repeat the process again. 7 in 47, that is 6. 7 times 6 is 42. 42 minus 47 rather minus 42 will leave us with a remainder of 5. That again is our final remainder. Repeat the process again. 7 in 6, that's 0. Since this 6 was not divided, we'll move it here as our final remainder. Therefore, my answer, starting from the bottom to the top, my answer to 2313 base 10 is equal to 6513 base 7. For example 3, we have 1251 base 10. We are required to change to base 16. Again, we will use the 16 to divide 1251. 16 in 1 is impossible. 1 and 2 gives us 12. 16 in 12 is also impossible. So we join 125. 125 and do 16 in 125. How many 16 can we get from 125? That is 7. There are 7 16 in 125. That is 7. 16 times 7 will give us 112. 16 times 7 is 112. Therefore, 125 minus 112 will give us 31. That's a remainder of 13. We place the 13 in front of the next digit, which is the last digit, and 16 in 131. 16 in 131. How many 16 can we get from 131? There are 8 16s in 131. 8. 16 times 8. 16 times 8 will give us 128. 128. Therefore, 131 minus 128 to get our remainder. This is 11. This will be 3. So we will have a final remainder of 3. We repeat the process again. 16 in 78, that is 4. 16 times 4 is 64. 78 minus 64, that will give us a remainder of 14. Which is the final remainder, because there are no digits left after 78. So our final remainder here is 14. But remember from our hexadecimal number base system that 14 is the same as letter E. So instead of writing 14 here, we write letter E. We repeat the process again. 16 in 4, that's 0. Since this 4 was not divided, we write the 4 on the right as our final remainder. The whole process of division ends now because we have gotten to 0. Now my answer, therefore, 1251 base 10 is equivalent to 4E3 base 16. Why don't you go ahead now and try these exercises? Number 1, 72 base 10, change to base 2. Number 2, 2122 base 10, change to base 3. Remember to post your answers in the comment section below. Thank you and see you in the next video.